It's my great pleasure to introduce the session today, and we've got three incredible speakers that will be coming up. I'll be setting the scene a little bit shorter than I was planning because we're running a bit late on the schedule here. So fortunately, I think a lot of the people in the room know a lot of these details already, so I can be relatively swift, I think. As I think many of you know, the food system is driving the majority of our environmental pressures. And if we look across the planetary boundaries, which are these thresholds beyond which we exceed the safe space for humanity on the planet, the food system is the second largest driver of climate change, as we heard, the biggest driver of biodiversity loss, the biggest driver of land system change. We heard about the deforestation earlier, the biggest driver of freshwater change in terms of blue water use, the biggest driver of these nutrient flows, which are damaging the marine environment, the second biggest driver of ocean acidification, the second biggest driver of aerosol loading. That was interesting earlier. Globally, it's true that it's the second biggest driver. But for Europe and for the UK now, because we've been having this energy transition, agriculture is fast becoming the largest driver of air pollution as well. And that's well mixed in the atmosphere, so that's in rural and in urban areas. And it's very high in novel entities. On top of that, we've got first for zoonotic diseases, likely the first for antimicrobial resistance. That's difficult analyses to do, but probably. And many of these boundaries interact with one another and with climate change. And the majority of the impacts are driven within this by animal agriculture. It varies between sort of 60 and 90-odd%. But this is the main driver that we have across these different boundaries. And so we need this great food transformation, which requires plant-rich diets, reductions in food waste, and improvements in production in our food systems. And we see, when we compare these different options, that shifting to plant-rich diets save the most emissions. So from the left-hand side here, we've got the emissions to 2100 and to business as usual. And then we have got the interventions of each of these different options that we have. And we can see here that plant-rich diets has the biggest option. We can see also these dotted lines in terms of the temperatures that we could have for these emissions as well. So agriculture on its own is enough to drive us beyond 1.5 degrees. Honestly, anything is now. So, it's not a big statement to state that, but it could actually push us beyond 2 degrees as well, depending on the uncertainties. It's critically important in high-income nations. This is a global picture, but in high-income nations, it can reduce our emissions between 60 and 75% from agriculture, and could actively lower temperatures, all other things being equal. And this is a really important point. This is our geoengineering solution. It is not solar radiation management and putting stuff into the atmosphere to reflect light. It is reducing the methane from the system, which will actively reduce the temperatures compared to where we'll be going. Some work that we've done in the past suggests that we have these other huge climate benefits. So we can reduce our emissions from agriculture by 61%, as I said, for plant-rich diets. But we can also spare land the size of the EU if we did this in high-income nations. If we did this globally, we could spare land the size of Canada plus India plus Brazil, large areas of the land on the planet. And by rewilding that, we could draw down about 12 years of global agricultural emissions. So we call this the double dividend because you're saving so much land. You've also got this climate benefit from drawing down onto that land. This is work that we did talking to experts, about 200 experts, climate and agricultural experts around the world, looking at what declines in livestock would be needed to meet the Paris Agreement. And you can see that this line is quite steep. We're looking at 61% reductions by 2036. This was the average of the responses. The important thing, and this comes back to this point about actively cooling the planet that I mentioned earlier, is you could avoid about 0.4 degrees of warming by 2100, and there's even a medium-term reduction of around 0.2 degrees if we're able to do this. And this is because methane has this different role as a short-lived polluter compared to CO2. So I want to go a step further for nutrition today, and I want to sort of frame this as actually not really a choice that we have in going to plant-rich diets. And that's because either we have food system attrition, where the impacts of climate change impacts animal stress, it impacts feed, it impacts the systems that provide us the food from animal agriculture. or we have a resilient transition, the likes of what I just sort of mentioned. And the reason for this is that I think that the impacts on the food system are coming sooner than we thought. Well, it's not what I think, it's what the scientific literature says. And this is work that I put together with a colleague that looks at the so-called burning ember plots from the different IPCC assessments over time, so from 2001 to 2022. And what they show is the risks at different temperatures for different impacts. So aggregate impacts on the left-hand side there, this is aggregate climate and ecological impacts, and large-scale discontinuities are these big tipping points, that's on the right. And so what we can see is that over time, we've systemically underestimated climate change. So what we thought would be happening at above 3 degrees of warming in terms of ecological and economic impacts is now slated to be happening in the danger zone today. Same thing with large-scale discontinuities, these tipping elements, but it's even starker. What we thought would be happening above 5 degrees of warming back in 2001 is now around 2 degrees at 2022. So I think this is really showing the systemic underestimation, and this is continuing on. I mean, we're getting closer as we're moving into this future that we didn't realize we were moving into, but we're still underestimating the impacts. Here is an example from the UK Climate Change Risk Assessment. In 2021, they said the better representation of the landscape and urban areas in the kilometre scale model have highlighted there is a very small chance, less than 0.02%, of exceeding 40 degrees by 2040. And of course we did that the year after, you know? And this is not to cast shade on the modelers, it's really difficult stuff. But what this is showing is that it's really difficult stuff, and we are consistently underestimating these impacts. When we look at the climate impacts on food, work out of Oxford and colleagues looked at the chance of these so-called multi-breadbasket failures, these reductions of at least 10% in global yield of various crops. And they found that the chances before climate change for maize was once every 16 years. Of course, we would always have some sort of failures. In some years, we'd be unlucky. As we go to 1.5 degrees, this goes up to once every 3 years, and once every 2 years at 2 degrees. Now, this is the most sensitive crop, but you see this dynamic across the different crops, and you see this across different papers. So what you're seeing, and I think is the really important point here, this big jump between the Holocene, how we love the Holocene, through to 1.5 degrees. And then we see another jump, but it's not quite as harsh, up to 2 degrees. So we're living through it now. I think the next sort of 10 to 20 years, we'll be living through this picture. So what does this mean? Of course, note that in Europe, about 60% of these crops are grown to feed animals. Well, it means we're seeing the impacts of this now. And in the last few years, if you've been reading the news, if you've been seeing, it's actually unfolding in front of our eyes. So we're seeing food price inflation increases, we're seeing big impacts on livestock and animals due to droughts. And research is showing that about a third of UK food price inflation was from climate alone. So this is pushing above the initial inflation that we're having due to, say, Russia, Ukraine, these sort of geopolitical impacts. The extreme summer heat in 2022 increased inflation between 0.5 and 1 percentage points, and there's potentially persistent climate inflation of 1 to 3% per year by 2035 on food prices. That's probably an underestimate. Whenever you look into any of these publications, there's always things that are missed. Science is difficult, it's difficult to get everything. How I think this plays out, and this is a very sort of just a schematic overview, is you have this cost of living that goes up and down all the time. But what climate change does is add another layer on top of that. And what you see as they accumulate, you can either have adaptation and mitigation, which brings this cost of living down, or you can have current policies which just continue on pushing up the cost of living all the time. And when you look at the cost of living, it's one of the biggest drivers in high-income nations of political instability. So we saw strikes due to cost of living, and in part you can say that that was driven by climate change. So climate change is already involved in our political instability around the world. I think that's one of the important factors today. And that's largely through the food system and largely through what we eat. Then we have food riots, then we have political instability as we go to higher and higher levels of cost of living. Okay, so, these are all scary things, and we're talking about things like these concepts of collapse of systems, these ecological systems that can actually provide us the food and the sustenance that we eat, and collapse of the political systems around us. And what does collapse really look like? So you start off in a simple state, you increase your complexity, say through the agricultural revolution. You have artificial fertilizer, you have mechanization. As each of these different steps producing the food, you get diminishing returns, and you get more and more impacts on the environment that actually supports the food that you're producing. And eventually, you have some sort of reduction in that complexity again. Now, the food system today is incredibly complex, both in trade across the world, but also through the supply chains, and largely through the animal supply chains in terms of how much land they take up. And so one question is, how do we cope with this simplification? How do we make things both resilient to climate change, but also improve the emissions, reduce the emissions from the food system? And the answer generally, biophysically, this is just a thermodynamic statement, is eat lower on the trophic ladder, and that means plant-rich diets. So I'm trying to bring this around. This is not just about the emissions, it's also about climate resilience. The climate resilience question and plant-based diets is a really important question that we need to be investigating. So we have many wins from these changes. We have land use, biodiversity, air pollution, water pollution, climate change, climate resilience, zoonotic diseases, antimicrobial resilience, animal welfare. I should say that even within each of these, your mind can go into different angles and different visions of a more wonderful future where if we are able to save a large amount of land, in the UK, if we ate an Eat Lancet diet, for example, we'd save almost the size of Scotland. You could imagine what that means for national parks, for access to nature, for mental health in a country that has one of the worst mental health outcomes in the OECD. You can take any of these things and then go off in these other different directions on health and just think about how it might improve the situation. One of the big questions, and that's the big question for today in this session, is dietary health. So what do these diets mean? For whom? And in what way? And I'm so excited to introduce our first speaker. And I'm going to introduce Karen Papier. She is at the University of Oxford.